Hey, I'm hoping this is one of those wonderful little extra videos that help you make connections between a variety of different things. So our task is to find the x and y intercepts of this shape. We're going to do this in several different ways. The first is through graphing and the use of geometry. So if we are familiar with this, we know it's a circle with center at 3, -4, and a radius of 5. And you might right away say, ooh, I see 3, 4, 5. And yes, you do. So let's graph it and see what you can do geometrically to find the x and y intercepts. So here's a circle, and if you want to find these points of intersection, you'll notice I kind of knew what was going on because I thought, okay, if this distance is 4 or -4, because you've gone down, this is 3, then we have automatically a 3, 4, 5. Yeah, the radius is 5, 3, 4, 5, right triangle. So this point 0, 0 is both an x-intercept and a y-intercept. Down here, if I look at the geometry here, I'm looking at, this is still 4, right? And this I've gone 3 across. And the radius is, of course, 5. So I'm really looking at another 3, 4, 5. So of 0, -8. And by the same reasoning of here's our 3, 4, 5, then I'm looking at this x-intercept of 6, 0. So I can do this completely using my 3, 4, 5 triangles. How sweet it is. Let's try a second strategy. And in that second strategy, let's start by finding maybe the y-intercept. So you let x equal to 0. So do a substitution, and then we'll check out a couple different strategies here. Okay, so here, notice that I'd had a typo, that should be a +4. Notice the consistency. I think I had it as a -4 a second ago. So now when I solve, I took plus or minus the square root. And this implies that y, one option for y is -8. This implies that a second option for y is 0, and that is completely consistent with our illustration up above. We can do the exact same strategy for finding the x-intercept. And here's the exact same process. Notice I get 0 and 6 here, which is completely consistent with our geometric representation up above. Let's try a third strategy, and we will sub in a 0 for x and then a 0 for y, and we're going to use a different algebraic technique. So hold on a second, let me set you up for that. So to find the y-intercept, let x equal to 0, and I can continue to solve y squared plus 8y plus 25 when I combine like terms. And I can, of course, these will cancel each other. I'll factor out a y. And then I can use the multiplication property of 0. I like to call it the MPOS, just because that sounds cool. And so I know either y equals 0 or y equals -8. Again, this is very consistent with the two other methods. So let's use this same strategy to find the x-intercept by letting y equal to 0. And there we go. 3 different ways. Let's look at a second one, because sometimes we get a result that is not factorable, particularly when we have an irrational number. We might need to use a different strategy. So let's start by graphing this and seeing if you can set up triangles to find the x and y intercepts strictly by using maybe Pythagorean theorem if you can't find a triplet. But graph this first and see if you can establish the values, and then we'll use the algebraic strategies to support that. So if we start with the x-intercepts, I've graphed, got a hypotenuse of that triangle that I've shaded in, and I think in terms of this, vertical is 1. I use the Pythagorean theorem to come up with that third side, and then I can establish this value, the x value. I'm at 2, there's 2, and I've gone to the right 2 times the square root of 2. Over here I've gone to the left 2 times the square root of 2, so I can then establish exact values for the coordinates of the x and y intercepts. Now let's do the same thing for the y. Okay, so I'm using the green triangle now. I know this horizontal is 2, and this vertical I'm going to call b. That's a b there. So I can say 2 squared plus b squared equals 3 squared. The hypotenuse is, of course, the radius. And I solve, and I get plus or minus the square root of 5 for that b value. So my coordinates are x value of 0, -1. That's where we started with the y value, minus the square root of 5. And then I have -1 plus the square root of 5 for the second. So now I've established those values. Let's verify this algebraically by setting x and y equal to 0. We'll use the same strategies in the same way that we did previously. There's this next strategy we used when we set x equal to 0 to find the y-intercepts, and we can see how we got indeed the same values. You can verify that these would be the same y-intercepts that we got geometrically up above. So let's now find the x-intercepts by setting y equal to 0 using this strategy. 2 plus or minus 2 root 2, and we can see that that is consistent with the illustration that we have up above. Now let's use the third strategy. It's not going to work quite as cleanly, so we'll have to use yet another skill from our toolkit. In this case, we couldn't easily factor. So if it's not factorable, couldn't easily factor, you just couldn't factor it. We used the quadratic formula, and we found, lo and behold, -1 plus or minus root 5. We'll notice that is consistent with our previous solutions. Using the same strategies to find the x-intercepts, we sub in a 0 for y. We find again we have a quadratic that's not factorable. To solve that, we use the quadratic formula, and lo and behold, we get the same answers that we got through using the 2 previous strategies. I hope you enjoyed this little video on making connections between the quadratic formula, between Pythagorean theorem, the triplets, graphing circles, transformations, horizontal, vertical, factoring. I mean, how many other things were in here? I hope you enjoyed this.